Hello everyone, and welcome to this tutorial on how to participate in the quantitative part of the competition for the Geothermal Experience. So how's it going to work? You are going to go into the CodaLab page, and you're going to go and first sign in and make yourself a user. So I made myself an example user, and you can kind of take a look around at the page so we can learn the details, the overview, the evaluation, terms and conditions. We can then go and look at the phases of the competition. So this is the main competition, and you'll see the final leaderboard on June 19th. Now, the first competition is based on half of the validation data, and the other half will be used for the view final leaderboard stage. So make sure not to overfit your data because the final evaluation is not on the exact same portion of the validation set. Then you're going to go here to participate, and you have to register. So you go here and you say, I accept the terms and conditions. And then you do register. Great. And then it says, your request to participate in this challenge is received and decision is pending. Now, by chance, I just got an email saying that I have to go and approve myself. So one moment, let me go in here. And I look, I recognize myself, and I say approve. Okay, great. Now we continue. So after, it might take, 5 to 10 minutes or maybe half an hour at most for one of the administrators to approve you. And then you go here and you say, okay, you should have gotten an email with a link to a Jupyter notebook that will help you get the data and then make your submission. But one last thing before we do that, let's go here into settings. And I know that this is kind of a group competition. So what you can do here is that once you know your team name, then you write it over here. So I'm going to write here Magic Geothermal right there. Great. And I add Pushpa Sharma to my team, whether he likes it or not. And add several other people while we're at it. Okay, and I'm going to click on Save Changes. And now this is an important step so that when you go and make your submissions that we know who you are and what your team is. Okay, great. So now let's go back to the competition homepage after we've done that. And we want to go and make a submission, right? So the way we do it is we make a submission over here, and we have 4 submissions per day per team. So maybe you should make a representative or just however you do that. But to go and make a submission, we have to have the data. And you're like, oh no, where's the data? But in this competition, we are not providing you with a clean data set. Rather, a very important part of this competition is for you to go and have the experience of data wrangling and creating the data set on your own. But before we go into that, let me go one step back. What is this competition about? So the idea is that while you are drilling, you can make a certain temperature measurement. For example, the temperature measurement over here, let's say that will tell you that the temperature of the formation around your well is 75 degrees Celsius. But the issue is that this is probably an underestimate of the geothermal gradient and of the geothermal potential in this area. Why? Because while you're drilling, you're actually cooling down the area around the reservoir, around the well with the mud, and therefore your measurement of the temperature will be an underestimate, right? So unless you do a temperature measurement sometime later after the circulation, then the bottom hole temperature will not be accurate. So the idea of this temperature is if we have the bottom hole temperature measured while drilling, and we have the temperature measured sometime later, we can go and make a model that will predict for the fields that we are dealing with what are the what is the connection between the bottom hole temperature and the final true formation temperature. So that is the task for this Datathon. And what we'd like to have then is obviously to have one input data where we have some information about the wells, and we also have the temperature that was measured while drilling, or the bottom hole temperature measured while drilling, and we'd like to predict the true temperature from that. So we would like to set up a table like this, but you have not gotten one, because one of your tasks is to go and create the table to go and predict the true temperature based on the bottom hole temperature and other variables that you can collect from the well data. So let's go and see how we do that. So you got a link to a Jupyter notebook that looks something like this, and it probably has to connect for you, but let me just, to give you the practice, let me kill my session, and so you have the experience from 0. And what you have here is, if you look here at this side of the table of contents, you see that there are several sections. One, setup, importing your data and some packages, then organizing the temperature data, so that you can go and see it over here, for example, the temperature bottom hole and the final true temperature. And then we gotta add in the mud weight data, the last files. So this is all about helping you set up the your input and label for the Datathon competition. So, and in the end, what you have to do is, for the training, for the testing set, you will have to submit the UWI, or the unique well identifier, and your predicted true formation temperature. So that is the goal, and let's see how if we can go and set up the data set. Okay, so what we see here is, for example, each one is kind of right now closed, but you could just open it up like this and see the different subsections. I just kind of closed it up for you by default so that it'll be easier, but let's open them up right now like this. And you can go here and import some great packages. Okay, so I'm going to click on Shift Enter. Another option is you can just click here on the play button. Okay, but I'm seeing right here it's still connecting, initialized, connected, so now it's finally ran. And when you see that finished running, it will show here a bracket and the number 1, or whatever number the computation is. Then I'm going to go here, and it's going to load the data from the organizer Google Drive. And you will see here that it's actually not going to immediately download, and it's going to want you to authorize yourself first. So this is going to be a little bit funky. You're going to have to go in here, click on your account, and then you're going to have to give permissions so that you can immediately download things into Google Colab. Then you're going to have to copy this over here and then put it over here, your verification code, like that. Got it? A little bit complicated, but it's worth the effort. And once it has authorized, you'll see it's going to start downloading things. I think in a few moments here, it's going to show all the different files that are downloading. Great, so let's wait for that. And actually, I think a really good idea to do so that we don't get slowed down is that we actually go here into runtime and then click on run all so that the whole notebook runs and I don't have to click and press every time. And I think this is also a good idea for you. But before you do run all, make sure to just do this step, step number 1.2, because you do actually have to do that verification step. Great. So right now it's kind of completing this one, and it will have to rerun it again. And while you're seeing all these files downloading, you're wondering, well, where is it on this computer? Then you go right over here into your files folder, and then you have suddenly here it says data for Datathon. That is basically what is loading in right now, so it's still working on it. This might take a few more moments. Let's see how it's making progress. I think it's almost there. Let's wait a moment. Okay, so I think I just waited some time for some of the cells to complete running. We see here that we downloaded all these files over in this direction. Then we're going to unzip some of the files. We see over here it's inflating a lot of the last files. And then we're going to set the paths of different subdirectories. Now that we're done with this section, just to keep it clean, let's close this and then go into our next section here. Number 2, organize eagle-bind temperature data. So like we said over here, we want to go and set up the table where we have the bottom hole temperature for the wells. Now we have 2 fields, eagle-bind and Duvernay, and so we're going to, because we got the files separately, one of the annoying things about putting data together is that you have to put in a lot of files together. So what we can do here is look at these 2 hidden cells, and it already ran this, so I'm just going to run through and explain to you what's happening. So we have the eagle-bind bottom hole temperature, and it's going to read the Excel file, and then it's going to see what is assigned the temperature in Celsius of the bottom hole temperature. So what we see here is that previously it was in Fahrenheit, so we have to convert it into Celsius. You'll see that we have 300 wells, And then we're going to read in the synthetic true formation temperature. So we have two kind of sets of true formation temperature. One is from synthetic data, and we're going to override that when we do have actual measured bottom hole temperature from a well log that has equilibrated. So a lot of the times in geosciences, you're going to have to mix synthetic with real measured data, and that's what we're doing over here. So then we're going to combine the measured bottom hole temperature and the true temperature by doing a merge. So we're going to work extensively using a package called Pandas over here, so I highly recommend you read on how to merge different data sets using Pandas so that you can get your data set a little cleaner. And you can see, take a look at it over here, we have the unique well identifier, some of the lat and the long, which will be very useful for you for plotting. And then we have the true temperature, and that's great. Then we're going to read in the static temperature information. So static is what I call the equilibrated temperature information, and we're going to also merge that into the data set. And then we're going to give it some priority, doing what's called a coalescing of the data. So giving first priority to the temperature from the static logs or the equilibrated logs, and then second priority to the synthetic model over here. And then we can see that we created a temperature Celsius final, and that is going to be over here in the back somewhere. Okay, kind of loading. There it is. Then we're going to plot it, and what we see here is kind of what we were expecting, that the temperature C with the bottom hole, if it was the same as the final temperature, it would fall on the line. And then we see that the true temperature formation is typically higher or much higher than what we measured during drilling. So the idea is that we would like to predict this temperature, this final temperature. Great, so now we organized the eagle line temperature. Now you have to organize the Duvernay temperatures. So let's see if we can see this hidden cells. We're going to first read in the, so for the Duvernay, we're not using the bottom hole temperature, but a drill stem test temperature as the input data that is not the accurate representation of the temperature. I'm going to read it in. Same thing goes. We're going to merge it in together with the synthetic temperature model, and also then try to merge it in the static temperature log data. And in the end, we're going to plot it, same as before. This is just kind of separate because the files are separate. And we can see that we already can see here that the kind of temperatures are a little different between the two fields. Then you're going to combine the eagle-blind, the Duvernay temperature data sets into one data set for the temperature data, and put it here into your structured data combined temperature file. Great, so that you got organized, and you can see it over here, all the temperature data. Now you're going to organize the mudway information wellheader and production data from all these Excel files. So I'm not going to go through the workflow in too much detail. Thank you, Krang, for writing this workflow. You can read through the files and try to flatten the data so that you have a unique well identifier and then all the data here in kind of a flat form. Okay, so there's different ways of doing it, and this is one possible way. So you can feel free to change the way that this data set is being created. And after you have all flattened all the data, you're going to get something that looks like this. Some things may be none a lot of the times. Okay, it's still loading a little bit here, but there is more data on this side. So, and sometimes it'll be none, sometimes it'll be values. Sometimes some of the fields, you see, you can have some values over here. So you're going to have to go and see what are you going to do to try to make this data more organized. We just gave you kind of like an example that will show you how you can do the data wrangling. A lot of the work is going to be on your side. Okay, then we have the last files. Thanks to Pushbash for organizing this section. You're going to go and import the great package, LAS or IO. So just reading LAS files, input output. And you're going to read and load in all the files, find out which curves wells are in each LAS file. So for example here, we have the name of the curve and one if it's in the specific well or not. And there's, I think, the well identifier. So that's great. And we can see which is the most common well type. So I think this is resistivity, and that's gamma ray. And if you don't know, I think Schlumberger has a great dictionary, so please use that. to figure out what you think will be interesting out of these possible logs that you could add to your data set and to do a better prediction. Okay, so this is for an example of how you can take, for example, if you want to look at the gamma ray and you want to add it in, this kind of shows you how you can do that. And then you can write that out here, your log data, again, into this structured data folder that you made for yourself. Then you can combine all of these data sources together. And you see that over here, how that's done. Again, using the Pandas merge functionality, I think. Yes, right over there. Great. And now we see that we have 836 rows and 333 columns in the data frame. Now we gave you one file that has what well is in training and what well is in validation. I think once you run it, you can go and merge with this data set and see which you should keep for the training. So for example here, you're going to go and filter out the wells that are in training, and then you can write out to a file that you can make for yourself called training.csv. Now, if you are just a beginner in all this Pandas world, then you can just run this whole workflow, and then what will happen is that you'll have a training.csv, and then you could just, I think we can even have a little insight here. You can just see that this is kind of a more classical tabular structure. You can just play around with this, and you don't have to deal with the data wrangling immediately. You can start first with this initial data set that just comes out automatically from just going here into runtime and run all, okay? And if you'll notice that you have also a validation set, and you will notice in the validation set, if I go here, validation data new label, is that you actually won't have the true temperature inside the validation set. So that's what you're kind of trying to predict. And let's see how we can go and predict that. And I'm going to show you here a very quick linear regression model. Maybe we can close these two to make some more space here. Okay, there we go. So you go and use sklearn, best machine learning package ever, and you're going to go and I'm going to use it predicting the true temperature only based on the bottom hole temperature. And this is kind of the data and the model that we predicted here in red. We can see it's not, it doesn't do a perfect job. There's a lot of noise. And then we can use the linear regression model to predict on this validation set. So there's the validation set that we just made, and we're going to make the prediction. And we're going to write the prediction to the CSV. Now, something that's very important about CodaLab is that you actually have to submit everything in a zip file format. So I highly recommend that whenever you change the model, kind of copy and paste this code to the end and use this to make a submission. Also, in order to not load the system too much, please only submit these two columns, UWI and true temperature. And also, it's very important to keep the column titles. If the column names are changed, then the scoring program won't be able to recognize it. Great, so this has already ran this whole thing while we were waiting. So what you have to do now is you go here into predictions.csv, that's it. And then you have to download it. So you're going to go and save file. And then I'm going to go put it here into downloads. And I'm going to go and click here. I'm going to replace it. I've already done this several times. And go here into my CodaLab competition. And we can finally make a submission. So we can call this my first amazing submission. Checking it out the scene. Submission, checking out my linear regression skills. Great. So I can go here, and when I click on submit, I am going to go into downloads and get my predictions. Great. And I think what it's going to do is it's going to say here, oh, submitting. Okay. Now I want to know, oh, what's my score? So it's still submitting, so I have to refresh status. Now it says it's running. And it's still thinking about it. You should give it a few minutes. So we have our separate cluster for running this. Right now I kind of made it pretty small, but if you think this is taking you too long, okay, now it's going to say an error occurred, and you have to go here and refresh your page. And then I got my score. Awesome! Example user has 11.752. Now the idea is to get a lower error, so good luck. That's your part of the competition. If we go on, also look here at results. We have my team name, a Magic Geothermal, and example user, and my score. And I think that's it. That's all we got. So, guys, good luck. Ping us on Slack if you have any questions, and let the competition begin.